Statistical Rethinking, 2nd edition, Chapter 13, and we're on question 13M4. So now this is kind of a continuation of 13M3. So what did we do in 13M3? In 13M3, we took a model from the book, this guy right here, which was a hierarchical model wherein, so the hierarchical part comes where we are estimating individual intercepts for each tank in the reed frog data set, okay? And a tank itself has its own parameters, okay? So this is the hierarchical part, okay? So we're getting separate estimates for each a tank according to these parameters, right? And so in the book, we modeled a tank to be drawn from a normal distribution. And in this question, we modified the distribution, the prior distribution for a tank from being a normal distribution to being a Cauchy distribution, all right? And so remember the Cauchy distribution is fat-tailed, okay? And so it's more permissive of extreme values, right? So you expect it to be more, to estimate more extreme values than the normal distribution on average, okay? So what is the consequence here? Okay, well the consequence here then is that, so with our hierarchical model, remember one of the consequences of this hierarchical model is that it pulls each estimate of a tank towards some kind of middle value, you know, that's being anchored by a bar. So it has this shrinkage effect. All of the estimates kind of shrink towards one another, okay? So when we replace that normal distribution with the Cauchy distribution, because the Cauchy distribution is more permissive of extreme values, we should expect less shrinkage from the Cauchy distribution, okay? And indeed, that's what we found with this plot right here, right? So on the y-axis, we have the estimate from the Cauchy model, and then on the x-axis, it's the estimate for the normal model. And so each dot is an observation. It's a tank plotted on its prediction from the two models, right? And so if a prediction is right on the red line, it means that the two predictions are equivalent. And you see that as we move up into more extreme values, the Cauchy distribution, being more permissive of extreme values, starts to deviate away from the line, getting bigger and bigger and bigger. Okay, and that's exactly what we expected. Okay, so now here in 13M4, we're doing the same thing, but instead of, well, so we're adding to all of that, okay? So we still have our two models from 13M3, right, where the hierarchical part is being modeled as a normal distribution and a Cauchy distribution, and then we have an additional model where we're modeling a tank as being from a student T distribution, okay? And we're going to compare the shrinkage among these three models, okay? So let's make a prediction here. So we've already seen what happens with the normal and the Cauchy distribution. Again, the Cauchy, being more permissive of extreme values, imposes less shrinkage on the estimates, okay? The T distribution is going to be somewhere in between the normal distribution and the Cauchy distribution in terms of the extreme values that it will permit, okay? So just for a little bit of context, if I have a student distribution, so this is my degrees of freedom for my student distribution, if I have infinity here, or a very high number, you know, as this number gets bigger, it approximates a normal distribution. As this number approaches 1, again, the normal, as the degrees of freedom for my student T distribution approach 1, then the student T distribution approaches a Cauchy distribution, okay? So the student T distribution is somewhere in between then a normal distribution and a Cauchy distribution, okay? And we should, well, I'm not going to say what we should expect in terms of, you know, where it compares relatively to these two things, how close it should be to these two things, but the student distribution is, with 2 degrees of freedom, is going to be more permissive than the normal distribution, but less permissive than the Cauchy distribution. So then we should expect for the T distribution, in terms of its estimates, to be to allow more extreme values, so hyphenated, more extreme values than the normal model, but less extreme than the Cauchy distribution. Okay, So here's my three models, and I've ran them, and so we won't sit here and watch that happen. And then we extract samples from the posterior distribution. And I'm going to bump this up because there was a problem with it. And then I'm going to plot the estimates for atank from the posterior distributions. Now remember, you get many samples. I think it's like 2,000 samples for each atank, and so I'm just going to take the call means of each of these. Okay, so we're going to plot this. I'm actually changing this plot a little bit, so let me actually clear that. So now the normal distribution is going to be these dark green. Oh, I think it's actually a triangle here. That's not right. Yeah. Sorry. Okay. So it's going to be the dark green. I think it's a triangle, and then the Cauchy distribution is going to be red dots, and then the t distribution is going to be these orange x's, basically. All right. So I'm going to plot this here. Okay. So I got the plot up here finally. So let's just take a look at this here. I think I may have I had to change some of this code here. So I may have told you the marker and the color, but they may not apply now. So let's just look at this. Okay, so what we have is we have each tank, just its index across the x-axis, and then its estimate along the y-axis here. Okay, for the different models. Now you see these alternating gray and pink vertical lines, and these are just, maybe to help you visually orient which estimates go with one another, right? Because this one is pretty divorced from its neighbors, and so you could just follow this down to see what its neighbors were. So anyway, let's think about what we see here. So remember that we had expected the Cauchy to have the most extreme values because it's the least restrictive. It's the most permissive of extreme values during the estimating process. And so we actually see that. So whenever you see some deviation, a lot of these are just right on top of each other. A lot of the estimates are just on top of one another. But when you get, kind of these where there's some spread amongst the estimates, it is consistently the Cauchy, which is these red dots, being the most extreme. Okay, now which is the least extreme in these examples? Well, we should expect it to be the normal distribution, and indeed the normal distribution are these green triangles here. Okay, these are the most normalized. Why? Because the normal distribution is the most constrained of these different models here. Okay, and then somewhere in the middle again is the t distribution, right? Again, when the t distribution degrees of freedom is infinity, we get a normal distribution, and when it equals 1, it's a Cauchy distribution. And so we have 2 degrees of freedom, so somewhere between normal and a Cauchy distribution. So we should see it to be somewhere in between the Cauchy and normal distribution in terms of the extreme values that it will permit, right? And that's, again, what we see. So these orange x's represent the t distribution, and we see that it's always in between, the normal and the Cauchy. Okay. Okay, I think that is all we have to discuss here.